different, whatever they said, right? London,
Yeah, so
Scotland, and Ireland.
England,
So there are
England, Scotland, Wales, and Northern Ireland.
So you are part of
England.
England. Okay.
Yeah.
You are part of England. Okay.
Do they use miles there or kilometers?
They use miles, yeah. So even if you're driving, it's a mile, speed limit is in mile per hour.
Right. Thank God.
Even, you will be surprised to, I mean, everybody pay in the liter, but they always call in gallon.
Yeah. Hopefully not degrees Fahrenheit, right?
No, it's degrees centigrade. Yeah.
Thankfully, because otherwise life in US, for example, gets so unusual when, say, the temperature today was 80 degrees.
Yeah.
What do you mean 80 degrees? We would be all burnt in 80 degrees. They said, no, 80 degrees, we don't burn. So
yeah, they do in Fahrenheit, yeah.
Right. What time is it in UK now for you?
Just 12.
12 o'clock. Okay. Yeah. So almost 5.5 hours.
5.5, yeah. So it will change in the end of this month. So then it will go 1 hour back. So then we have difference of 4.5 hours.
Okay.
So they call daylight saving.
Okay.
Yeah.
And your university is opened, or your online work is on? I mean,
it's online still, yeah. So there's a plan that after Easter, the government guidelines says probably we will go back. But this semester we are not going back because it's only 2 weeks, and we thought it may be too much work to be completed to invite all the students, and then you have to change a lot of plans for a timetabling and all this. And it would be mess. So we decided, okay, this semester it will go as usual, like online mode. And it's very optimistic here that they will open from September. So here semester start in end of September until January, and then February to April. So it's very short here compared to India.
Okay.
Yeah.
Okay.
Yeah. So we also have other faculty colleagues. Maybe we can just have a round of introduction.
Yes.
So we have Professor Pennan, Narayanan.
Yeah. Professor Bakul.
Hi. Good evening. Can you hear me? Hello. Am I audible?
Yes, please.
Yeah. So this is Pennan Chinnasamy. I'm an assistant faculty at Sitara, and so I teach mostly hydrology and GIS and remote sensing. So looking forward to your talk on livestock and other energy associates. Thank you.
Yeah. Thank you.
Hi, I think since everybody else is silent, this is Professor Satish Agnihotri. I'm now an emeritus fellow in Sitara. I teach, my areas of interest are nutrition, child nutrition, rural technology, and energy and gender.
So, quite close what I'm doing. Yeah.
Unusual mix, but look forward to your talk.
Thank you. So,
hello. I'm Subodh Wagre. Hello.
Sir.
I'm also a faculty in Sitara, and my area of work is more on policy side. I work on energy policy, water regulation.
Okay.
Work on electricity regulation.
Thank you.
I also take interest in some kind of a technology dissemination or technology understanding.
Yeah. That's what we do.
Hello, Dr. Pandey. This is Amit.
Hi, Amit.
My area of work is, I think that intersects quite a bit with yours. We look at bioenergy sector very closely.
Oh, okay.
We also look at waste management, agriculture value chain analysis, and as Professor Agnihotri was mentioning about nutrition.
Yeah.
So I also do a little bit work there as well.
Oh, that's good. So it's good to know expertise at Sitara. Maybe let's see in future, probably if there is some call that we can we might able to collaborate and work. Yeah.
Yeah. Look forward to your presentation. Yeah. Thank you.
Yeah. Thank you. Thank you very much. Yeah.
Hi, this is Dr. Rupal here. I'm a pediatrician and I've been working on child malnutrition for past 14 years. So I'm here in IIT since last 2 years. So my focus is basically child undernutrition, maternal child health and child undernutrition.
Yeah. Okay. Yeah. Thank you.
Nice to meet you.
Yeah. Same here.
Dr. Pandey, this is NC Narayanan.
Hi.
I work on water and sanitation governance.
Okay.
Yeah, all the best.
Oh, thank you.
Good evening. This is Bakul. Sorry, I don't have a camera in my office.
Yeah.
Yeah, I'm also a faculty here with Sitara. I work in the area of rural planning, monitoring and evaluation, and also in the area of water and sanitation.
Okay.
Very nice to hear you.
Yeah, thank you.
Yeah,
thank you.
And some part in the area of solid waste, that too for small towns.
Yeah. So yeah, I'll try to be concise, not to overrun to this seminar. So try to focus particularly on the animal waste. So yeah, if we have any more introduction, I've been
I think
with Sudha and
yeah, we were in communication, Dr. Pandey. This is Naren Shah here.
Yes, sir.
My PhD was on pyrolysis, was in France long time ago.
Oh, good to know that.
Right, but currently I teach agro-based industries, and then I have also some dabble into biomass fuels, and also nutrition is another subject that I teach and research on.
Oh, yeah. Okay. So yeah, it's a very wide range Sitara is covering, starting from energy to nutrition, malnutrition, GIS mapping. So yeah, it's quite interdisciplinary research group. So yeah, good to hear. And I would be also be looking forward to have your feedback on my presentation. Maybe I will also learn something from this member, those who are attending. And yeah, you might give me some hint where I can focus more and some further area to research, to explore.
Yeah. So Professor Anand can either.
I think just two more people. I think Pankaj is here. I think.
Pankaj
So Vishal is here.
Okay.
Just half a minute, maybe. Pankaj, you want to introduce?
Hello.
Hi.
Hello.
Hi.
Pankaj, we are not able to hear you. Maybe in the meantime, Vishal, can you introduce Vishal?
Yes. Thank you, Professor Shah. Thank you, Anand. Hi, Daya. This is Vishal Pandey here.
Hello.
I am an adjunct faculty over here, and I work in the domain of energy, appropriate technology, and I work on empowering small businesses, particularly in rural areas.
Okay.
And a few of my areas of working are turmeric processing, jaggery processing, and all. Okay. Thank you.
Thank you.
So I think either Sudha or Abhinav will introduce the speaker, and then
yes, sir.
Yeah, Dr. Daya can take on after the introduction. Yeah.
Yes.
Yeah. Thank you.
So good evening, one and all. Welcome to the Sitara seminar series. Today with us we have Dr. Daya Pandey. He is a senior lecturer in the School of Computing and Engineering at the University of Huddersfield, UK. He has won 5 collaborative EU projects and leading 2 GCRF funded projects on agri-food innovation. He has previously served as a Ruskin Fellow and lecturer at Anglia Ruskin University and a research fellow in the RCUK Centre for Sustainable Energy Use in Food Chains, Brunel University, London. At RCUK CSEF, he worked on the optimizing energy demand in industry to reduce carbon emissions, waste to energy conversion, and the system integration. He received his first degree in mechanical engineering in 2008 from Integral University, a master's degree in energy engineering in 2010 from IIT Delhi. He earned his doctoral degree in thermal process engineering from the University of Limerick, Ireland. Dr. Pandey received the prestigious Marie Curie Fellowship from the European Commission. His doctoral thesis was focused on energy and nutrient recovery from animal waste. Before his PhD, he worked as a senior engineer in the project execution department at Brahmaputra Cracker and Polymer Limited. He has published more than 15 referred publications. Dr. Pandey's area of research involves around resource recovery from agri-waste, biofuel production, nutrient and energy recovery from animal waste, sustainable farming, food, energy, water nexus, rural economy, sustainability, and decarbonized agriculture sector. Dr. Pandey is a member of the UK Research and Innovation Early Career Research Forum. He is a chartered engineer, a member of Institution of Mechanical Engineers, and a fellow of Higher Education Academy UK. He is also recognized as a promising global talent in his research field by the Royal Academy of Engineering UK. On behalf of the Sitara family, I welcome you, sir, and we can now proceed towards the session. Over to you, sir.
Yeah, thank you very much, Avino, for your kind introduction. I'm pleased to be here. I hope I will enlighten some of the area that I'm working on. So hopefully you will find my talk interesting, and please feel free to give me your constructive feedback, or if you have any questions, please feel free to ask during this seminar session. And I'm really glad and privileged to have invitation from Professor Rao, and also having been coordinated with Professor Shah. So thank you very much for giving this opportunity, and yeah, and the kind introduction. So I'll just go through talk what we are supposed to be here. So to start with, I'll just give a brief introduction why this area is very important, looking into agriculture sector in terms of global prospect, but also as well as I will be looking into agriculture sector in Indian context. So this sector is contributing about 1/3 of total GHG emission that coming from any anthropogenic sources. And as per the UN FAO, Food and Agriculture Organization, they estimated the livestock is the major contributor in agriculture sector, counting about 7.1 gigaton of carbon dioxide equivalent per year, that's originating from anthropogenic sources. This also employs overall in global context about 1.3 billion people in the sector, formally or informally. And it accounts also 40% of total GDP of the world. And this is also a major source. 1/3 of the humanity protein is coming from the livestock. So this is very important sector. We have to look into it. We cannot ignore, because it's contributing more than 40% in GDP, is providing 30% of the protein for humanity intake. So in terms of coming to the EU context, where I'm particularly working, the share of GHG emission from livestock is about 11.3%. And you would be surprised to see in terms of looking into Indian agriculture sector, this is also a kind of similar mapping out what in the global context. But India, as we know, is our mostly agriculture-based economy. So our economy is 23% of GDP coming from the agriculture sector, and about 60% of the total workforce work in this particular sector in agriculture. Coming to livestock, just giving a comparative analysis, what is happening in the EU or in global context versus Indian context. So if you look, the global livestock sector is about 15.5% of GDP contribution, and 41.5% of workforce working in this particular sector in livestock. Moreover, if you look the EU and Indian context, the GHG emission is slightly higher in Indian context, and there is some factors, because here in the EU, you are very much regulated. You have to fulfill certain protocol. You cannot dump your manure in the field. You have to go for the nitrate directive and fertilization directive. In India, we don't have that much strict regulation, and that could be the reason why we have higher GHG emission coming from the livestock sector. So compared to EU, it's 11.3, but in India, we have about 18%. So I was going through this before giving my talk. So I was also collecting some data. So I was looking some MNRE report, and they also pointed out that if we use the animal slurry, and that has about 80% carbon. This carbon can be used for the energy, but again, another important source is NPK, that is the macronutrient for our agriculture sector. So we can also decarbonize our agriculture sector, but at the same time, we can also recover energy in terms of biogas, syngas, depending upon what type of feedstock you are having and what process you are going to use to process the manure. So this is the context in terms of global meat production. This is the data until 2013. About 315 million tons of meat is being produced for the humanity intake. And out of that, the poultry litter is about 100 and so again 1/3, and then buffalo meat is 60. So this is again poultry sector is also a major contributor in the meat sector. Moving on, so this is an estimation from the United Nations. They predicted in 2016 about 1,387 million eggs were produced. That's equivalent to like every 1 egg per human per day on this planet. So this shows also here one statistics I'm presenting about the UK. In the different meat sector, the poultry sector has a highest reported highest growth rate between 1995 to 2015, and that's accounted about 32% increase in the poultry sector. The recent report from the FAO Agriculture Outlook, if you want to refer this report, it is projected that the global livestock production is expected to increase by 14%, and they have categorically mentioned that the poultry sector would be the fastest growing meat, accounting almost half of the total projected growth in the meat sector. So why this meat, why this poultry litter is very much focused in all this livestock sector, and why this is important, and what are the key drivers why this particular poultry sector is very having higher growth rate. So the few things that plays a very important role in this sector is production cycle. So compared to if you're looking cow, buffalo, or goat meat, it has a shorter production cycle. Here in the EU is map out 6 to 8 weeks, and after that it has to be hatched and new batch arrives. So it has a higher production cycle, and it responds very quickly to the market signal. So if market is going for higher poultry meat production, poultry meat consumption, so it can reflect quickly and produce that much poultry meat or eggs that's required to meet the demand in the market. Compared to other meats, these poultry meats are cheaper, and this is also an important factor how the market growth and the growth rate is being reflected. It also provide product diversity. So here in the EU market, you can find the free-range chicken and organic kind of. So this is different type of product diversity. Is also offer what consumer wants. So it's not only one type. It can give you organic farming. You can also have egg or meat that is from free-range chicken. So free-range chicken is not in the cage. They go out in the open. So of course it needs much more land, but for that you have to pay a bit higher price. But this provides the flexibility in terms of product diversification. I was looking in terms of India, how the India is doing, and there's a very recent report from this Poultry et al. It's published in Poultry Science, and I looked and I was amazed that annual production in India is about 851 million birds per year in India, and it has reported the growth rate of 8.51 and 7.52 in egg and broiler production, compared to, if you look the growth rate in our agriculture sector, that is 2.9%. So in terms of, and also this poultry sector alone, giving into our economy about $17.31 billion into the economy, and it employs 50 million people through direct or indirect employment. India is also a third largest egg producing country and the fourth largest broiler producing unit in whole world, and producing about 103 billion eggs and 4.1 million tons of broiler meat per year. Looking into Maharashtra, it was very important fact to find that Pune in Maharashtra is one of the 5 highest egg production region. There other is in one is Kolkata, and there's one in Andhra Pradesh and in Tamil Nadu. But Pune is also mapping out in Maharashtra is also one of the 5 highest egg producing unit. So why I was very much interested in this. So if you look, you can see there's a slight, very big deviation in terms of how much poultry one bird is producing, how much litter or manure. You can see it's amounting 1.5 to 5.7, and it's basically what kind of comfort or what type of bedding material you are providing. It's not all poultry manure, but it's including the bedding material, what type of comfort, what you are providing wood chips, or you are having a straw, you are providing feed, or even it's also include the feed that you are giving to the chickens. So it's all include. That's why it's called poultry litter. It's not called poultry manure. So, but this also has a high calorific value comparatively to. It can be compared with the traditional biomass. So if you look in terms of as received basis, the calorific value of this poultry litter is about 8.75 to 14.27 gigajoule per ton. And this can be also for a source of valuable organic fertilizer. So if we utilize this poultry litter, if we process it in a sustainable manner, we can recover energy, but at the same time, we can also recover the nutrient that can goes to our agriculture sector and help to decarbonize our agriculture sector and making us less dependent on fossil-based fertilizer. So in terms of EU, about 1.4 billion tons of animal waste is generated in EU 27 countries. UK is now out, but when I took the data, it was UK was a part of. So EU 28 countries in the EU. So they produce almost 1.8 billion tons. So this amount of waste, if you want to put in the land, there's a nitrate regulation and fertilizers regulation in the UK, in the EU. So you cannot put your raw manure into the land. Per hectare is the limit is 295 kilogram per hectare. So obviously the available cropland that's available for the direct application of the manure is not enough to cope up the demand of the manure generated, and this was basically due to intensive farming. In the past, it was like organic farming. Everyone has some small number of chicken having, but due to increased demand of protein and changing of lifestyle and economic development, the growth of the demand of animal protein is increased, and that led to the intensive farming. And when you do the intensive farming, you always generate much more manure that can be taken up by the nearby cropland. So if you dump it in your backyard of the farm, it can lead to ammonia, nitrous oxide, and odor emissions. The contaminant, the heavy elements in the manure that can go into the groundwater, and it could cause water contamination. The nutrient, if there's a rain, it will run off with the the nutrient, and it will go to nearby pond or river, and it could cause a eutrophication into your surface water. But also it could be a source of vermin and pathogen causing diseases, and it could have impact on your farm, on your crops. So these are some factors that may be resulting, having bad consequence on our atmosphere and aquatic life as well. However, if we process it sustainably, we can recover energy. So this is the waste, but we can recover energy. But at the same time, we can also recover a nutrient, and this nutrient can go into the cropland, offsetting part of fossil fuel-based fertilizer to be used in your agriculture sector. So I'm mainly focusing on thermochemical conversion process. There's a different type of, so you have to be, when you decide which path to take, you have to see what is your feedstock. So of course you can see here there's a cow, but if you want to use the cow manure, it's not very good feedstock for going to thermochemical conversion process. The reason behind it has too much moisture content, so you cannot go really for the thermochemical conversion process. But I'm focusing more on thermochemical conversion process. The reason behind I'm using a poultry litter, and poultry litter is having less moisture content. So around, if you are from boiler or production unit, the moisture content is below 20% most of the time, because you have to provide much better comfort. You use the bedding material like pulp, paper, wood chips. So this reduces the moisture content in the poultry litter. And that's why I'm focusing more into thermochemical conversion process. But if you have a high moisture content feedstock, you can always go to anaerobic digestion. And then, of course, you can see here anaerobic digestion. So if you want to have, then after the effluent, you can separate the liquid, and the solid part again can go to the drying process. And again, it can be used for the thermochemical conversion processes. So my area is basically to look into energy recovery, as I mentioned, and also looking into the fertilizer, how we can use these materials that be recovered from the thermochemical conversion processes of the animal manure, how we can utilize this as a fertilizer. So, of course, Professor Shah has worked in this area, so I'm just giving a bit of context what the gasification is. So gasification is a partial oxidation process. So it is a part of thermochemical conversion process. You can see at the bottom, and it's basically categorized based on the equivalence ratio. So if you look, the equivalence ratio is basically how much amount of air you need to combust that particular biomass or feedstock versus what is actually you are feeding into the reactor. So, of course, the biomass is not traditional fuel like methane or ethane or propane. So you have to look into the elemental composition of your biomass or feedstock, and then you calculate how much amount of air is required to combust it fully. So this is the correlation that if you want to calculate how many kilogram of air you need to combust 1 kilogram of such kind of fuel that has carbon, hydrogen, oxygen, and the ash content or sulfur content. So based on that, you can calculate the equivalence ratio. So when you say how much amount of oxidizing element you are providing, so that means how much you are feeding into the reactor. You are not taking into account what is already with your feedstock. Like in biomass, you always have some oxygen inherited into your feedstock. So when you say equivalence ratio is 0, so that means you are not feeding any external oxidizing medium into your reactor. It's basically called pyrolysis. Then it comes to gasification. It is the equivalence ratio is 0.1 to 0.4. You might find some paper or literature. You can see the gasification is being done as high as 0.6, maybe 0.7. In some simulation, they can go up to 8. But this is not really gasification, because then you are leading to more combustion. You are start to combust more biomass. However, if you want to do more autothermal condition, so if you go for autothermal, you have to combust, because these are the endothermic process, and it need heat to sustain the chemical process. So in that case, maybe you can go up to about 0.5, 0.6. So you have to compromise on maintaining the temperature of the reactor. You have to combust and make it autothermal. And in combustion, normally, if you look at the chemical reactions, if you have a 1, equivalence ratio is 1, you can say it is completely combusted. But to ensure its complete combustion in combustion process, you always fed more air that is actually needed. That is stoichiometric. So you always put a bit more than what is actually required. So I'm working on poultry, as I mentioned, because this is fairly dry. And that's why I chose to go with the thermochemical route. Another reason you might ask, why not anaerobic digestion? So another reason, one is the moisture, but the second reason is also it has dry matter content. So if you have a dry matter content in your feedstock, this is not really good. It slows down your anaerobic digestion processes. So, and again, thermochemical conversion process has a require less time to process the same amount of biomass. So if you have a poultry litter of 1 ton, you can process it in a day. In anaerobic digestion, it might take 30 days, 40 days to go through the anaerobic digestion process. Of course, you will have some difficulty dealing with the high dry matter content in your poultry litter. Here's the proximate analysis as received basis. You can see in this particular feedstock that I used, it was 22%. It still is higher side going in thermochemical conversion. If we can do a bit of drying, you can bring it down to 20%. So normally it is advisable if you have more than 20%, don't go for the fluidized bed gasifier reactor. So another important factor probably you will notice the 14% is ash, so that may be a problematic. I will be discussing in the next slide. And the amount of alkaline earth metals, that's part of the ash content, and that could cause some problem in your fluidized bed reactor. However, if you look the volatile matter content, it's accounting 57%, so that can be easily converted for the energy. And this could form the syngas, or also having more benzene, toluene, and that can also be used as a building block chemicals for the pharmaceutical industry. And depending what you want, and based on your need, you can plan your experiment and look what is your desired output, and then it can help you to also act as a building block for the chemical production. So just to give you some more concrete information, so when you look in the ultimate analysis, it's always better to put in dry and ash-free basis, because the moisture and ash content will not contribute in terms of your energy content. So if you look more realistic, what is your dry and ash-free basis component? So here I'm giving you a comparative analysis of poultry litter and wood pellets. So wood pellet is basically a traditional biomass that normally being used for the thermochemical conversion processes. So if you look the carbon, hydrogen, they are very compatible. Even in poultry litter, you can see they are higher compared to traditional biomass. But the worrying point is nitrogen, sulfur, and chlorine contents. These are very high compared to the traditional biomass. So when you gasify or pyrolyze it, so they will have issues. You will be having sulfur containing compound, chlorine containing compound, and that may affect the application of your product. So if you produce a syngas, there will be also hydrochloric acid, there could be H2S, there could be ammonia. These elements, if you don't clean it, you are not really saving the environment, but you are more polluting, because then your turbine, you are combusting them, it will form the H2SO4, causing the acid rain and so many problems. So you are also contributing to more to greenhouse gas emissions. So it's better to burn it or go for another process rather than going into gasification route. So I will be explaining how we can do this, how we can address these issues. So if you look in the ash content, that's what I was talking about, where you can recover the nutrient. So you can see the phosphorus pentoxide. So it's the phosphorus. Also, if you look at potassium, and these are the high element. The concentration in the poultry ash is very high. So you can recover these NPK, and then it can be replacing part of your fossil-based derived fertilizer, and it will help you to decarbonizing your agriculture sector. And also probably those who are working in this area, organic farming is becoming a new trend. And here in Europe, mostly if you have any organic product, it costs more, but still people are buying it because they say we are not having any chemicals in our products, so it will be good, healthy. So this is another new norm that can also help us in terms of sustainable farming and improving our costing for our products that we produce in India or anywhere in the world, having a tag of organic farming. So I did experiment. I also do modeling, but I will be presenting most of my experimental data here. So we run the gasifier in the range of 700 to 800 degrees centigrade. We wanted to go higher, but we encountered agglomeration problem. That's what I was discussing. So this work was done in collaboration with the EU project with Energy Research Center in Netherlands. So this is the fluidized bed gasifier. So you have a biomass hopper and the reactor, you fed it, and after the gasification, we also have a cyclone where we remove all the dust particle or fine particle, and then it goes to the, for the syngas analysis, it has to go through the hot and cold filter where you again trap any tar or any contaminants so that it will be clean product gas going into the going into the micro GC to be analyzed. Of course, here we were not, the gasifier unit was not connected to any downstream unit. So most of the syngas that we produce, it was put in the flare and combust and put into the atmosphere, because the idea here to look into research perspective, what are the potential we can get. So, and this was the very first study conducted in the fluidized bed reactor, and based on the novelty of this work was also highlighted in Advances in Engineering, considered as the key scientific contribution in the science and engineering area. So when you have those elements like potassium, phosphorus, sodium, they are in higher concentration in your ash content, so they normally start melting at around 750 degrees centigrade, 700, 750 degrees centigrade. And if there's not enough calcium, so they form a compound that has lower eutectic melting point, and thus when they start melting, so you can see here the figure, so they start binding to each other and they form the agglomerate. And if this is happening, it will block your fluidization. And if fluidization is not proper, the temperature and pressure in your reactor will start varying significantly. If this happens, because your reactor is not anymore smooth running, and there's a temperature and pressure blocks are happening in different regions, so you cannot ensure that your reactor is working properly. And if this happens, you have to shut it down, your operator, clean it and start it again. So we encountered this problem at 750 degrees centigrade. So when I was doing this experiment, so we come up with the idea. So if you add the limestone is basically source of calcium. If you add the calcium, it will start reacting with potassium and phosphorus, forming the calcium phosphate and calcium silicate, and this has a higher eutectic melting point, and it prevented the agglomeration up to 800 degrees centigrade. However, I would like to mention here again, after 800 degrees centigrade, we wanted to go higher. Even adding the limestone to the reactor didn't help. And again, we encountered agglomeration problem at 850 degrees centigrade. So we didn't run any more experiment, and we decided it's not worth to add more limestone to just avoid agglomeration. And I will show some data where we got what we have to do when you recover the dead material and cyclone acids in terms of looking the nutrient. So this is the comparative analysis I wanted to do when I added the limestone and when poultry litter was gasified without the limestone. So you can see there's a significant drop in terms of hydrogen and the carbon monoxide. So this led to also lower calorific value. And if you have a lower calorific value, you also have low cold gas efficiency. So these are reflected, but here one important point you can see in the figure number from top, second figure, the ethane concentration was dropped significantly when we added the limestone. That also reflect the limestone has the catalytic property, and that reduces the tar content, and that's again is reflected in figure number 3. The total tar content when you have when I added the limestone reduce compared to when poultry litter was gasified alone. So again, it's an important discovery from this. So the limestone was also helping to react secondary tar cracking and primary tar cracking process. So of course, once this happened, we decided that we will use the poultry litter blended with the limestone, and we used 92% in terms of what previously was done, previously you have used, most of the researchers used the limestone in the bed, or use the different bed material like bauxite or calcite that has higher calcium content. We went to another approach and we start feeding the limestone to be reactive throughout the process. We started to add 8% of the calcium oxide along with the 92% of fertilizer. So the idea is not to have only once in the bed. That might help you at the beginning, but keep feeding continuously the limestone that will be there in your reactor, and that will also help throughout and not decalcite. So in this case, just presenting one result here, we were testing the temperature effect in terms of at particular fixed equivalence ratio is 0.3. You can see, of course, because it's an endothermic process, so when you increase the temperature, it improves the tar gasification, and it also influenced the water gas shift reaction and Baudard reaction. So due to water gas shift reaction and Baudard reaction, you can see there's an increase in hydrogen and carbon monoxide. And due to favoring of tar cracking, you can see again in here, ethane concentration is going down. And that also reflects that if you increase the temperature, it will also improve the tar cracking process. And this tar cracking also reflects the increase of other light hydrocarbon content in your syngas. So because of that, you can see, if you look this lower heating value, you can see at 750 degrees centigrade, the calorific value of syngas produced was the highest. At 800 degrees centigrade, you can see, as I mentioned previously, it is favoring, but when you have a higher temperature, the Baudard reaction is producing CO, but the CO is being consumed into water gas reaction and forming the CO2. And that if you are having more CO2 concentration in your syngas, that doesn't contribute to your calorific value. And that's why there is a slight drop in lower calorific value. But carbon conversion efficiency, of course, it doesn't matter if you are forming the CO or CO2. So it's looking mostly how much carbon was in the gasifier and how much carbon was converted. So we achieved around 80% of carbon being converted to the into the syngas. Of course, you will also have a tar. So when I'm presenting this carbon conversion efficiency and hydrogen conversion efficiency, it is not taking into account the hydrogen and carbon present in the tar. So tar is basically heavy hydrocarbon. So if we include those, maybe our carbon conversion efficiency will go about 90%, and hydrogen conversion efficiency will also go 60 to 70%. 60 to 70%. And it is also reported based on the dry basis. So if you encounter again the moisture content in your syngas and in the bio oil, you will have almost 100%. So that's where remaining hydrogen or carbon being left out. So looking into the most complicated factor that I discuss, where they go in terms of chlorine, sulfur, and nitrogen. So during, if you go through thermochemical process, the only disadvantage this have, if you go through anaerobic digestion, you still have most of the nitrogen recovered in your slurry. If you go to thermochemical processes, they normally form ammonia, and they mostly go into the gas phase. So we found out, of course, there is some error. You can see at in nitrogen in the product test we reported 101%. So uncertainty, some measurement issues. So it is accounting more than 100%, but the range is between the acceptable limit. So I just want to report it here. But we also find the same kind of research being produced by other researchers. So if you go any thermochemical process over 700 degrees centigrade, most of the nitrogen associated with the biomass goes into ammonia because the temperature is not high enough. And if you are talking about the gasification, so you are not also having enough oxygen, the possibility of producing NOx is very less. The reason behind the NOx is basically depend on how much oxygen you have, what is the temperature you have, and then what the activation energy you need to convert nitrogen into NOx. And probably you were aware about the Jeldovic mechanism. Normally it occurs around 1000 degrees centigrade. So here we were operating about 800 degrees centigrade. So it is mostly forming ammonia. In terms of chlorine and sulfur, if you look here in this
Dr.
picture,
Pandey, sorry, just to interject. So these percentages, so what are exactly they representing? Because
so
you start
if
with
you have
100 in the.
Yeah. So if you are, if I'm explaining like here, if you have 100% chlorine, so chlorine means if you have 5% chlorine in your feedstock, so I'm terming them as 100%.
Yeah, but then in the Sankey diagram, they don't all add up to 100, no?
Yeah. I completely agree. So
what happens to
there is some measurements that we were not able to do, and you can see in chlorine when it was with limestone, we were using the bomb calorimetry and it didn't ignite, so we couldn't measure how much chlorine was in the bed ash. So it's written NM.
Okay, but no, even in other Sankey diagrams, I don't see the tally.
No, it's not adding up. So there's a discrepancy. Of course, it's if you look the sulfur even, it's getting closer, but sometimes it's over 100, sometimes it's less than 100.
Okay, fine. So this is interesting, but I think you have how many more slides you have? We have time.
So I will go quickly. Yeah, sorry.
Okay, thank you.
Okay. So we also looked into the participation of different elements. What is happening? This was done in the faeces calculation. So when you have a limestone, it is fixing. It's leading to fixation of solid form in the bed material. Similarly, a similar result was found in case of chlorine. So when you have a limestone, it start forming KCl, NaCl, and CaCl2, and that's remain in the bed. In terms of potassium, the limestone reduces the amount of potassium in the liquid phase. So if you look, so on the left is without limestone, and on the right is with limestone. It is about 7%, but it increases the gas phase. So when you have a higher temperature, so potassium start volatilize and it's going into the gas phase, and calcium also helping and acting as a catalyst. So this one I did a pyrolysis, Professor Saad was mentioning. So I will just go quickly here. Before the biomass in the first two react coolers, we recover the pyrolysis oil. And the remaining other 3 and 4 is basically used to collect all the condensate, and mostly they were content of water is very high compared to in 1 and 2. So here, those who are aware of the phosphorylysis process are basically used to maximize the organic liquid content. So this is basically you are trying to produce more bio-oil. However, in case of poultry litter, when we pyrolyze the poultry litter, it was not the case. And the reason behind, if you have a high ash content in your feedstock, it doesn't lead to a highest bio-oil production. Rather, you will see a higher biochar production, and there is some pyrolytic gases evolved during the pyrolysis process. So pyrolytic processes, I tested at 2 different temperatures, and that temperatures hydrogen increase, and that indicates that lignin start decomposing at higher temperature. The carbon monoxide basically is linked to tar cracking. When you go higher temperature process, the bio-oil, initial primary bio-oils, they start cracking, and it's leading to more CO production. And other light hydrocarbon is basically leading to secondary cracking of volatiles. So during your pyrolysis process, methane or other component that's being formed, and they start again cracking and forming lighter elements. This is the bio-oil content. In terms of, I would say here, the moisture content in the bio-oil we found is over 27%. So it cannot be used in a combustion unit. The limit prescribed for that is about 2%. So this is much higher what is supposed to be used. Important factor when we analyze bio oil is total acid number was in the range of 40s at both temperature. One was 38 and one was 46. In these cases, and again, if you look the guideline, and the stand number is basically reflecting the quality control of lubricant. So in this case also, this cannot be used as a fuel for aviation or even gas turbine or engines because it's exceeding the limit. But this could be a potential source for lubricant additive. Looking into recovery of the elements, we recover in most of the cases about 80%. As I mentioned, you can see the nitrogen recovery is below 20%, about 20%, because most of the nitrogen goes into ammonia form and it goes into the gas phase. So these things are very important in terms of looking at the nutrient recovery. So this is here we are talking about the biochar, unconverted carbon along with gas content in the feeds. So there is certain regulations in place. This is DEFRA, Department of Environment, Food and Agriculture sector in rural settings here in the UK. So they have some guidelines. So if you want to utilize ash that's being produced through thermochemical conversion process, you have to fulfill these criteria. If you are not fulfilling these criteria, it cannot be categorized as a potential fertilizer. So you can see from this table, except arsenic, cobalt, and zinc, most of the elements are exceeding the limit. So it was categorized that the fly ash that we recover from the cyclone, it cannot be used as a fertilizer to put into your land, because rather than helping the crop, it may be contaminating the soil. So to conclude, kind of, according to EU fertilizer unit, there's a recent regulation came into effect. It also allows that thermochemical conversion during oxygen limiting conditions, so like basically pyrolysis or gasification, if they recover any elements, it can be used as a component material for the fertilizer. So looking into our ash from cyclone and bed, so we found the cyclone ash that we investigated, it meets the criteria for H to C ratio. It has to be below 0.7 and the chlorine content has to be below 3%. However, the total carbon content in cyclone ash that we recovered, it was 12 to 20%, but it exceeds the limit that also says your carbon content in the ash should not be more than 3%. So again, it's failing one criteria, so we have limitations to use. In terms of bed ash, we found when poultry litter alone was gasified, it was fulfilling the criteria, most of the criteria, but when poultry litter was mixed with the limestone, it was not fulfilling those criteria. And again, the carbon content and H to C ratio was much higher compared to what is specified by the guideline. In addition to that, we also find that most of the phosphorus was recovered in cyclone ash, but they were not water soluble, and it was only 2%. We did the leaching experiment, so it's only 2%. And the guideline says that if you want to categorize your product as a fertilizer, it has to be at least 25% water leachable. So therefore, here you have to look, further research is needed. So whether we should use the cyclone ash, and if we specify the poultry litter is much lower temperature, probably that would help rather than adding with the limestone, because if you add the limestone, it's not meeting the criteria. Or maybe we have to look at something different to extract the phosphorus. I also did one experiment looking into the combustion, but again, when you do the combustion, you have a problem of aerosols formation. So this is also, I'll conclude my talk. So my research is basically centered around utilization of rural energy resources, and that trying to make off-grid connected community self-energy sufficient, looking into nutrient recovery and sustainable farming. That will, of course, lead to organic farming. I'm also looking biomass or waste conversion technologies. So basically, I'm focusing more on thermochemical conversion route, producing the biofuels, as I mentioned, the phosphorysis process. I also do modeling, process modeling, and the data-driven modeling approaches. So I am exploiting, I have already looked into it in the solar energy and biomass area. Issues resolved so far, that's been working. Nutrient, major and minor nutrient, validation with the EU fertilizer products regulation. That's what I was talking about in JRC report. How we can gasify the poultry litter that has high ash content, and what could be other possible synergies that we can link with to improve these processes. And then when we're using the data-driven modeling approach, how it will help to look into the potential, whether this particular technology is suitable for looking into energy recovery or not, this particular feedstock is suitable for this thermochemical conversion processes or not. And what techniques I have used, I'm using experimental setups like fluidized bed reactor, pyrolysis reactor, hydrothermal carbonizations. But at the same time, I'm also using the process simulator, exploiting data-driven modeling approaches. And then one work that I used using genetic programming is also being featured on the bioresource technology paper. So thank you very much for your attention, and I would be happy to answer any question if you have.
Thank you, sir. Participants can raise their hands and we can take the questions in the respective order.
Shall I release the screen?
Sure, sir. Yeah. Deepak?
Good evening, everyone, and good afternoon, there, sir. Thank you for the presentation. So actually, I have just one or two few technical questions. Yeah. There was a mention about 259 kg per hectare of this animal waste can be used. Yeah. So this is a what's the time frame in this? Is it per year or per month or per decade?
Yeah, no, it's per year. So this is basically adhering the nitrate directive of the EU. Because if you these also have high nitrogen content, so you cannot put too much animal-based manure on your cropland, because that will lead to higher nitrogen, and if there's a high nitrogen, it will run off the rainwater or irrigation water and cause the eutrophication in the surface water.
Okay, thank you, sir. And sir, in a slide there was a mention about the efficiency, the amount of gas that we were able to retrieve. So in the top graphs, when there was an individual look, it was in slide number 12. So when we look at it individually, we see that with the use of limestone, we were able to retrieve more and more gas. But at the lower graph, we saw that there was not much difference when we looked at the overall efficiency of the process in terms of gas retrieval.
Yeah. So because
yes.
you can. Yeah.
Yes, sir.
So of course you can see there's a change, but if you look the unit, because the unit of the gas yield is presented normal cubic meter per kg, but here on DAF basis and nitrogen free. But the one I present here about gas yield, it also includes the nitrogen. So that basically balances the pack. And that's why you can see the much difference in your gas yield.
Okay, sir. Thank you, sir. Got it. It's clear now. And so one final question. It was about, I think it was on slide number 21 about the fertilizers. So, or 21 or 20, 22, sir. Sorry, sir, 22. In slide number 22, yes, sir. So in this, here, this arsenic and cobalt, are the only one who are not able to, because of which we are not able to satisfy the need, and we have to reject it as a fertilizer.
As a fertilizer. So this is the fly ash analysis that we recovered from the cyclone. So if you look the arsenic, cobalt, and zinc.
Yes, sir.
So the protocol is in the middle. So this is the protocol that you have to look when you are looking in your fly ash or any type ash content and trying to see if it is matching the protocol.
Okay, sir. Sir, if we can add this arsenic, cobalt, and zinc separately, then will we be able to satisfy the need?
No. It's only these three things. So arsenic, cobalt, and zinc are meeting the criteria because protocol says 17, but we have 11.
Okay, sir.
So
it should be
this is
less
the
than
maximum limit, the protocol.
Okay.
But if you look the copper, is the specified limit is 31, but we got 271, 274.
Okay, sir.
So it's much higher. So you cannot use it as a fertilizer. So I think what you are talking about is opposite.
Yeah, okay, sir. There was a confusion about it. Okay.
Yeah.
Thank you, sir. Thanks a lot.
No worries. Thank you, Deepak. Thanks.
Thank you, sir, for detailed presentation. I wanted to know that is it efficient to use biomass gasifier for 1 to 2 hours cooking application, or it's better for using producer gas for electricity generator?
Sorry, I didn't get you.
So if we use a particular biomass gasifier just for cooking for 1 to 2 hour application, not a continuous for 14 to 15 hours. So is biomass gasifier a feasible solution?
So in terms of, because I think something.
Yes.
Yeah. So in this case, like when I presented the syngas, of course you have the contaminants. So if you do the gasification of poultry litter, you cannot use in your engine because this is exceeding the tar content limit. It also has higher impurities. So what you can do, you can use it in your cooking purposes. That doesn't require very sophisticated high quality of syngas, but or you can use this syngas in your brick factory, like where the brick is being produced. You can use this and as a fuel for the brick making factories, but it cannot be used in very sophisticated internal combustion engine or gas turbine. So you can use it, but you have to again clean it. You have to do a bit. You have to clean the impurities that associated with these syngases, like H2S, hydrochloric acid. So this is all in the syngas. You cannot use in your internal combustion engines or any turbine or boiler.
Shah, sir.
Yeah, Dr. Daya, what generally one understands that, and as you mentioned in your proximate analysis also, poultry litter has got a high nitrogen content vis-a-vis if you compare with like paddy straw, wheat straw, and things like that. So the general advice is like, mix this poultry litter into these kinds of, agricultural residues so that you get a C to N ratio, which is sort of, good and optimal for anaerobic digestion. And then in anaerobic digestion, also you get that fertilizer value. So what I'm trying to say here, now, if you take these two routes, like one is pyrolysis, combustion, gasification as a thermochemical route, and then propose ash as a fertilizer value, I would put anaerobic digestion on a much higher hierarchy to use the poultry litter to add it to the agricultural residues and use as a sort of, so you get a better fertilizer and you also have a methane, which you can sort of use as a sort of, gaseous fuel, which is sort of can be burned directly in IC engines and things like that. So what is your thought on this?
Yeah, yes. Thank you for this this question. So we also tested this still again thermochemical, having blended poultry litter with the traditional biomass like beech wood. So it's 50-50. Again, this was done to encounter the defluidisation or agglomeration problem. So coming to your question, of course, this can be used as an anaerobic digestion process, but here it use some agricultural waste like paddy or other thing to balance the C/N ratio. That's okay, but the reason behind here the having lower moisture content and also high dry matter content, and this is the reason why I looked into thermochemical route. Of course, if you have like a cow manure or any other manure that has a high moisture content, thermochemical conversion route is not way to go. But in this particular case, also this thermochemical conversion process technology also being used for horse manure. Because horse manure is also having very high dry matter content and less moisture. Of course, it has a high moisture content compared to poultry, but that's why I said, and in my concluding slide, I did mention that we also have to look thermochemical conversion processes, gasification, pyrolysis route, but again we have to look into the synergies if we can link it with any other biochemical or anaerobic digestion processes. So my take here, sir, my opinion for such kind of biomass where the dry matter content and moisture content is low, and you can see also the volatile matter is quite high, it is worth to go with the thermochemical conversion processes because the processing time is very less, and at the end you will only deal with the remaining 15% of the ash. In terms of anaerobic digestion, again there's some issues. It takes longer process, but when you have your effluent, so you still need a lot of storage if you are not able to immediately use it.
Okay, Abhinav, next question.
Yes, sir. Priya ma'am.
Yeah, hi, can you hear me?
Yeah, I can.
Okay, hi, Dr. Pandey. Yeah, so my question was that these technologies, can they be used by the rural people for their benefit, for the betterment of their lives or for their incomes? In the sense that, what kind of capitalization might be required to set up such plants and something like that kind of thing.
Yeah. Thank you very much for this question. So in terms of having this technology deployed in a rural community, of course, it's need skilled people. So you cannot expect a personal, normal household person and go and operate the pyrolysis or gasification unit. So in terms of capitalization, so here in the EU, there is some combustion unit, gasification and pyrolysis unit are operating at commercial scale. In Netherlands, there's a plant that's solely running on the poultry litter, and they're producing 36 megawatt of electricity. So again, I visited that plant. I've been there. So after talking to them, it is apparent that even having this plant running, it is processing your waste that of course you have to process it. But they said to run this plant, they need subsidy. So of course here, you want to deploy this technology, initial investment from the government is highly expected. So because maybe it has payback period of, I haven't done the techno-economic calculation, but if you are expecting 10 to 15 year payback period, so initial investment from the government initiative would be highly appreciated here if you want to deploy this technology in rural community.
Okay, but what is the smallest scale of the plant that is viable? Like how many megawatts?
So in terms of if you want to make it viable, such kind of plant, you have to go at least 5 to 10 megawatt, at least 5 megawatt.
Yeah, no, okay, fine, yeah. So that would be quite expensive, right?
Yeah. So that's why I'm saying like the capital investment, it has to be coming from the subsidies, some government initiative.
Okay, but also the raw material, then the quantity of raw material will also be pretty large.
Ma'am, here when I don't know the mechanism in India, but like when I visited this plant, because the intensive farming, and the amount of manure is being generated by the farmer, so they want to get rid of this because of having to fulfill the directives from the European Union. They were paying 50p per ton to process their waste.
Okay.
So I would say in terms of rupees, you can say about 40 rupees per ton of poultry litter. And they also bear the cost of transportation, because it's also bulk density is very low. So in a truck, you cannot load more than 5-6 tons.
Okay. Okay. Thank you.
So, and they were like paying to the plant.
I see. Okay. Thank you.
Any more questions?
Just to take it forward, so when you say 5 megawatt plant, so then in terms of the input, what kind of poultry size you think can support that plant?
So in terms of having this the amount, that plant was processing about over 200,000 ton per year. So if you scale it down to 5, maybe we still need at least 5 to 6 ton per day.
Yeah, I mean, what number of birds? I mean, the poultry size related to
Sir, I'm not aware of in Indian context, but here normal said is 50 to 100,000 bird. So this kind of plant is suitable where we have like more. So when I'm looking this data, maybe Pune region could be where they have a lot of poultry farm. In that region, it can be deployed. But we have to look at how much poultry litter is being generated from by those farms.
Thank you.
Amit, sir.
Hello. Yeah, Dr. Daya, I have just a couple of, I think, clarifications. So one is, you have shown these details. So here you are saying proximate analysis, which I just see on your screen right now.
Yeah.
So I was trying to understand proximate in different terms. For example, the real proximate composition analysis. So when you really break the biomass down into, say, how much carbohydrate and protein and ash content you get, do you have those numbers?
I do have, but I don't remember at the moment. It is presented in my paper. So if you want to have a look, so you can.
No, partly I'm asking this question just to understand what would be the best approach to be able to utilize this biomass, right?
Yeah.
So right now we are looking at, of course, thermochemical pathway.
Yeah.
And I mean, based on little work that we have done in gasification route, I feel, and also taking up the point from Dr. Shah, Professor Shah, I think I have little different view on this. What I was thinking, when you are looking at nitrogen ratio, nitrogen content, I would see this is pretty high in this case.
Yeah.
So when you do anaerobic digestion is going to pose their own challenges.
Yeah.
Right. So it's not going to be that straightforward technically. So that would have its own issues. I mean, keeping that aside, my real question I wanted to ask was, so how can you, so if our target is to say extract and recover few elements from this biomass, have you thought of strategies to separate these individual elements from the residue? Like, for example, concentrated phosphorus recycling, and what methods can we apply to do that?
I haven't done, but the recent project that I have with Nigeria, Agri-Food Africa, is again looking into poultry. So as you rightly mentioned, the nitrogen content is very high. So what we were thinking, maybe before pyrolyzing it or gasifying it, maybe if we can recover, drive off the nitrogen in terms of ammonia, recover it, and then when we produce biochar, maybe we can infuse that ammonia to increase the nitrogen content in the biochar that can be used as a fertilizer. So this work is ongoing, but I don't have the data to present.
Okay. And any thoughts on phosphorus? Because phosphorus, I would say that that's much more precious.
Yeah, much more precious. Yeah, this is the very important aspect, particularly because geopolitical as well. So it is only available in some African countries, Rwanda and all this. So it's a very important nutrient for the agriculture. And that's why a lot more focus is being focused on the phosphorus recovery. So unfortunately, there's another paper that is coming up soon where we did all the leaching experiment and other thing. Unfortunately, I have to report that during thermochemical conversion process, what we recovered, the phosphorus, was not water soluble. So they were a much more stable compound, and it is more leachable through the NH4AC, ammonium, and also through HCl. So again, this is posing another problem. If we go through the thermochemical route, can we utilize the recovered phosphorus as a fertilizer or not? And that's why in my last slide, I said probably we have to look at different strategy of the extracting the phosphorus from these resources. In addition to that, I also did the hydrothermal carbonization, where because if the moisture content is a bit high, we can also go for hydrochar and looking into, and in that case, we find most of the phosphorus was recovered in the water. But then amount of hydrochar be produced, because hydrochar also bound a lot of phosphorus. So the amount that be recovered in the water, that we can look into the speciation of these nutrient value going into agriculture sector. But again, what we have to with the biochar that's still remain in the biochar, the hydrochar, I would say hydrochar. Okay. So it's still there's a gap to look into how we can more efficiently recover phosphorus, and that can also be categorized as a component for component material for the fertilizer.
Okay, so just a quick follow-up on that. So yeah. Do you have any figures in mind? What should be the recovery cost for, say, 1 kg of phosphorus from litter, when it actually makes, you know, complete sense techno-economically?
To be very frank, I haven't done that, so I don't want to give any speculative answer. So sorry about that, but I cannot give any particular figure how much it will cost and such kind of thing.
Okay,
so,
yeah,
but I haven't done it.
That's completely okay. So I was just wondering, in one of the slides, I think Deepak was asking a question on slide number 22.
Yeah.
So the slide number 22, I saw some numbers. I was a little sort of intrigued by this, especially selenium.
Yeah.
So how come selenium is so very high in this fly ash?
So this is and again, Deepak here, I would say, but poultry litter is very heterogeneous fuel. So if you take from one farm to another farm, it may be different. Particularly the one we tested, this is what we find through the ICP analysis. And the source of selenium is still is not very clear why it is so high, but this is what it is, what we found in the ICP analysis. In terms of chromium,
and in fact, the same thing goes with copper and mercury. So both are pretty high.
Yeah, in mercury we found so for the chromium also because the wood chips was used, so we found probably some used material or something. Because of that, maybe the chromium is very high, and mercury is still again we found it should be 0.5, but it's 4 in terms of poultry litter. But again, it's not very clear why is so much high mercury content in the fly ashes.
Okay. Yeah,
I have the elemental composition of initial of the poultry litter, and then looking into the fly ash. These elements that be presented, they're based on their volatility, because they're volatile. They release during the gasification, but when they land into the cyclone, because of the high carbon content of the cyclone fly ashes, because of the small particles, they start condensing in that region and then remain with the fly ash. And that could be the reason why it is very high in fly acids. In bed ash, they were much lower concentration.
No, but I think if you have, say, complete mass balance of your actual material, raw material, we can definitely figure out whether these numbers are making sense or not.
Yeah, I did for the pyrolysis one. So that is already published, this report. So I did the mass balance analysis. How much was in the biochar, and the remaining was found in the bio-oil, the amount of small particles that goes through into bio-oil, and also the remaining, it was only 5 to around 5%, and we expect that was gone into the volatile phase. So in here, in the pyrolysis experiment, I did the mass balance analysis of the element, and that is what here I presented the major elements that we recovered in the biochar. So biochar and the ash together at the end of the experiment.
Okay, thank you.
So you can see still the ash content is not 100%. So again, something is gone through fly ashes, and maybe something land up in the bio oil.
Yeah.
Yeah.
Okay, thanks.
Yeah, thank you.
Bakul ma'am.
Yeah, Dr. Daya, nice presentation. Just to take ahead what Professor Arora said, the slide number 22 about selenium.
Yeah.
So I was just wondering what type of an ICP did you use? Because selenium is very volatile.
Okay.
And also one other slide you had where you had P2O5 as 18%, where you also mentioned you used ICP.
Yeah.
So what type of an ICP system you used?
So it's optical electron OES spectroscopy linked with the ICP.
So it was an OES?
OES ICP, yeah.
And not an MS?
No.
Because ICP is not considered a good method for both phosphorus as well as selenium. So was there any hydride you used for selenium?
Ma'am, this experiment, the sample I supplied, and they did the experiment. So I don't have much idea operating the ICP or OES.
Okay, so because one of the things is selenium is very volatile, so you need a hydride generator. So maybe because of that, there may be, is it, so I was just wondering, is it really so high or some error?
Probably, I don't know, ma'am, but as you mentioned, the selenium is highly volatile, and this is the reason they land up in the fly ash, not in the bed ash.
Yes, but you are analyzing ICP using ICP, which itself has a very high temperature, and before detecting, it just volatilizes.
Yeah. So it could be possibility, but yeah, we can look into it in more detail. Probably, as you suggested, maybe we can look with MS, and probably it might be better.
The same is true with the phosphorus. Usually you never use ICP AES or OES for phosphorus as well. So yeah, maybe.
Ma'am, I'm not an analytical chemist, so yeah.
Okay, thanks.
But yeah, it's a good point. Maybe I will next time analyze this through using, you suggested MS, yeah?
Vishal sir.
MS may be better, yeah.
Okay, thank you.
So there we were doing some brief research on poultry for biogas. Okay. And one of the things we found that the fresh poultry litter has a lot of moisture content. Okay. So the ammonia content is also very high.
Very high, yeah.
Yes. And there were in India particularly, we use bedding material as paddy.
Paddy,
Paddy. Okay, now in such scenario, I don't know the composition of paddy and poultry litter. Okay, but I have two questions. Paddy contains a lot of ash. Okay.
Yeah, and silica.
Silica, yes, silica.
Yeah.
So how it will behave in gasification process? That's question number one. And the question number, just to follow that, is how much moisture is expected so that there should be a reasonable flowability in the gasification process for this material?
Yeah, so thank you, sir. For thermochemical route, I think if you go over 20%, then you are utilizing too much energy during your drying process. So it's not really feasible to go over 20%. So coming to that one about the moisture content.
Moisture content. Okay.
Yeah. So even here is 22%. So we've been through, but it's always advisable if it is. Of course, if you read the gasification technology, there's a fixed bed and up drop, down drop. So sometimes you can go higher gas content. Again, if you have high moisture content in feedstock, it will be taking a lot of energy that's being generated during gasification process, basically to dry it out. So it doesn't make sense to go very high moisture content through this route. Coming to this process about how this will behave, because it has high ash content, so it will also adding up in terms of maybe in Indian context, if we analyze the poultry litter from Indian context, maybe the ash content will be higher further. And if there's a high silica content, what happens, sir, if you have a high silica content, and then if there's of course there will be phosphorus, potassium, so they start forming the phosphorus silicate of those materials, calcium silicate, phosphate, and these has lower melting temperature, and if if the silica content is high. So in this particular case, sir, when I used silica sand as a bed material. Okay. And because of that, and having this phosphorus, potassium, sodium, and they start reacting with the silica. And if you don't have enough calcium, if there's a calcium coat on silica particle, and it form like a bone dry material, and that's also avoid the agglomeration. But if it is not there, so it will start melting, and then only possibility in terms of looking the nutrient and operating the gasifier smoothly, probably we have to run at low temperature, around 700.
I see. Okay.
Otherwise, we will have a slag, and if a slag is formed, they start then forming the agglomerate like this, and then your bed is defluidized. So it will not be properly fluidized. Your temperature and pressure start rising here and there. So you cannot operate your gasifier smoothly.
Okay. Just another question. How is it possible to scale down the technology? Because typically in Pune region, the poultry sizes, barring big guys, there is a system integrator approach, So there are integrators who do this based on, based on big players giving them the poultry batches.
Yes, sir. Yeah.
So they are typically, typical shed is 10,000 bird shed. Okay.
Okay. Yeah.
And a farmer is having a good farmer having 3 or 5.
Yeah.
Okay, not more than that. So we are talking about 50,000 birds.
Birds.
Okay. So there is one means, is it possible to scale it down? And the other, some quick question is it possible to keep on removing this poultry litter and keep on feeding, or we have to remove it when the batch is complete?
So, sir, I'm not aware of the how it is done. I'm also from a village. In my village as well, I'm from Uttar Pradesh. So in my village also, I have seen they have some of the my villagers. Some of them got contract from some big players, like what you said, and they are also having the poultry shed in my village as well. But they are only housing 5,000, 10,000 birds, max total. It's only one shed. So I don't know how it is done in India, but here one batch is 6 to 8 weeks. This is European regulation. If you look in the US, it's 6 months. So it depends, sir. And here in Europe, once batch is cleaned, once batch is taken out in 8 weeks time, you have to remove all the litter. You have to sanitize the shed before you put in the new batch to avoid any pathogen or contamination to the new batch. So this is the regulation here in Europe. So the shed has to be totally cleaned. All the poultry litter has to be removed after the batch. In India, sir, I know, like I'm from village, so the guy who has 10,000 bird, the amount of litter generated is meager, and it can go to nearby cropland. We have a lot of agricultural feed.
Yes.
So
yes.
I don't see that problem in India. This is more when you have intensive farming and like having a set of 50,000 bird, not only one set, maybe 10, several sets that you have a big farm.
Okay. 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 Thank you. Thank you, Daya.
Yeah. Thank you.
Thank you, sir.
Yeah, just to clarify or follow up on that. So when we are categorizing this as poultry litter and not specifically manure, so this will come in only a long duration batches, is it? On daily basis, this litter won't be generated.
No.
When we compare it to other animal waste like cow dung, so that is the main difference I see. I mean, in terms of running any kind of a plant.
And that's the reason, sir, Rao, sir, here, because when the batch is finished, you have an enormous amount of litter generated at the one point of time.
Yeah.
So you need
then,
quickly
but if you want to run a gasifier or any other kind of a energy generating unit, then you need to have intermediate storage of this waste, right?
Yes, yes.
And then any studies or any understanding of what happens to this litter when it is stored temporarily? Is there any degeneration? Is there any emissions from those?
So, sir, the one plant I visited in Netherlands that's running on producing electricity 36 megawatt. So, of course, they have a continuous supply of poultry litter because there is several farmers around the area. So it's not everybody's finishing at one point of time. So they have a continuous supply, but they also have the storage system. So when you have this store, of course, it has to be under shed. There's a decomposition, and if they have surplus amount, what normally they use here in Europe, rather than storing for longer term, they use it for the mushroom composting. Because the poultry manure is very good for the mushroom production.
Okay. So that is a competitive use or more predominant use of the poultry litter right now?
Yeah, so if they are not processing through thermochemical or going through biochemical route, normally if this manure is produced, they put in the shed, bit decomposed, not a raw one. But after that, they use it for the mushroom production.
Okay. So is that considered as a better utilization of this waste?
It is, but it is not solution for the enormous amount of waste generated.
Okay, so it cannot consume all that is produced.
No, it cannot consume all the poultry litter that being generated.
Okay. What about any other composting options?
Because they don't really use for the anaerobic digestion. The reason behind having high dry matter content, high nitrogen content, such kind of thing. So mostly some farmers, they have small units. I have been when I was in Ireland. So there's two brothers, they have their own small scale farm, but they have the fixed bed downdraft, updraft gasifier, and they produce some heat for the heating the shed. They don't produce electricity. So they use updraft gasifier, produce heat for the shed. And the biochar they utilize in their own cropland, but they are a small farmer. It's not a big intensive farm.
Okay, interesting. But given the lot of consciousness about climate change issue in Europe, especially, I mean, people should be, or industry should be very worried about the overall emissions. And given the high nitrogen content in the waste, they have to be extra careful in terms of the emissions. So,
yeah. So, sir, when I joined the Brunel, I was working with a company project. It was Facenda, is a big one of the leading poultry meat producer here in the UK. So they were not only interested about the poultry litter, but they were also interested looking into what we have to do in the processing unit, because in processing unit you have all the feathers and the carcass and all these, what we can do. And nowadays a lot of push here in the UK or in European Union to decarbonizing the energy system, whole energy system, heating, cooling, electricity. So they were, and also this kind of provision, if we have also in India or another country, maybe it also push here in the UK. If you produce electricity or heat from renewable resources, so animal waste, such like poultry litter, is also considered as a renewable resource. But you have to categorize how much, because in poultry litter also you might have some fossil based feedstock included in the litter. But if you produce this, then you will claim RHI, so they call renewable heat incentive. So if you produce electricity or heat, rather than buying electricity from the grid or something, you can claim the money from the government saying that I'm producing my own electricity and the government will pay you.
Okay, interesting. So yeah, I think
so. Such kind of thing in initiative is it helpful. And as I said, sir, this kind of setup, if you want to set up in a rural community or even in big scale, the government subsidy would be definitely required. Otherwise, I don't think at this stage industries would be very much interested in deploying this technology by their own.
Okay, thank you.
Thank you, sir.
Amit, sir.
So I'm not sure whether we have time for another question or shall we?
Yeah, Abhinav,
please go ahead.
Yeah. Okay. So Dr. Daya, these couple of things that have come up in discussion, Professor Vishal Sadash Pandey asked a question and Professor Priya Jadhav asked a question.
Yeah.
So one question that they were asking is, how low can you go on this?
Yeah.
So I'm just wondering if that is the question, and then you're also worried about, the moisture content of the feedstock. Why not downdraft gasifier when it is much more forgiving when it comes to moisture content compared to the fluidized bed gasifier? So that's one. Yeah, I think we can probably go with this first, and then
I think the what you are asking, maybe fixed bed gasifier like updraft or downdraft be better reactor for such kind of feedstock. I completely agree, because then you will not have defluidisation or agglomeration issues in your bed, and it's also much simpler in terms of operating fluidized bed gasifier. But the advantage of fluidized bed gasifier, this work, if you look in the literature, there is several work already being done. Professor Anna Malai from Texas A&MU, he did a lot of work in around 90s to around 2000, 2005, that area, using the poultry litter, having fixed bed gasifier. So this one, I wanted to look how it will behave. And of course, fluidized bed gasifier has a higher capability of going the upscaling problem. It can solve the upscaling. So that's why in Netherlands, they have the fluidized bed reactor when processing the waste. So of course, if you want to look for large capacity, bigger scale plant, maybe fluidized bed technology is way to go. If you want to have a small unit deployed, decentralized unit, maybe gasifier is much better. And it also handles the moisture content as well. But again, I would suggest if you have too much moisture content, whether it is fluidized bed gasifier or whether it is fluidized or fixed bed gasifier, it will have consequences on the performance.
Right. But I think the amount of moisture you mentioned, it's roughly about 20%. I think downdraft can handle this much. Yeah. And you can go as low as 5 kilowatt system.
Yes.
So that is the biggest advantage in rural context, Indian rural
content,
context.
Yeah. Right? But I think so the moisture content, yeah, you are right. Like it's 22%. But again, I just would like to mention it totally depends what kind of environment you are providing to the chickens. So it mostly depends what type of bed material you are providing. So moisture content is totally dependent on this.
True. No, I understand that.
Because you have your you have the pipeline for the water, so and chickens it's not all drinking, and you will drip the water and all this. So
yeah,
it mostly depend on the bedding material. And again, what the professor, I think I forgot the name, what he was saying, when it will be cleared out, the shed. How long? You take 6 months, you take 1 year, you take 6 weeks. So that also depends.
Right. So another, I think, follow up on Professor Rao's question when he was talking about, all this climate change issues and nitrogen and all that.
Yeah.
So one thing I was thinking, the reason I asked you that proximate composition, if we know how much protein this particular feedstock has, basically this protein is essentially, it's a proxy for nitrogen.
Yeah.
And, you can do pre-treatment and remove this protein up front. The moment you have removed this part, then you will not face these kind of processing issues later. And your gasification process will be much more smoother compared with the one with the original feedstock.
I completely agree. So if we do the pre-processing, so maybe we can then only focus on lignin content.
Mm-hmm.
So if we have a lignin content, we can go even for the better bio production process. And other one that I mentioned, like if we go removing the nitrogen before gasifying or pyrolysis, if we remove the ammonia from the feedstock, it will also, again, if you remove ammonia and phosphorus, it will also prolong your reactor life. Because if the phosphorus goes into your reactor, this can be also corrosive.
Yeah, but my this guess was, if you can remove protein, you will get concentrated protein.
Yeah.
And this concentrated protein has its own market, because this
so
poultry feed, poultry litter is also used as a feed, but that's not concentrated protein. It's about say 15-20%.
Yeah, I heard it being used for the in the fish pond.
Exactly. So the moment you have got very concentrated protein, now you have a totally different market for it. You have taken care of climate change, and now you have concentrated biomass feedstock, which is apt for gasifier.
Yeah. So if you do pre-segregation, of course, it will ease more difficulties that you are facing at the moment. So if you have only lignin content, cellulose, hemicellulose, and lignin, it is very good feedstock for the thermochemical conversion process.
Sure. Okay.
Yeah.
Thank you.
Yeah. Thank you.
Thank you, sir. I request our head, Professor Anand Rao, to present the vote of thanks, and we shall conclude then.
Okay, thank you so much, Dr. Pandey. I think the nice discussion that we had after your presentation, that is a testimony that it generated a lot of interest in our students as well as faculty to know more nuances about this work. It would be nice to see how such a thing could be applied for scaled down versions in terms of our own context here. I think the way you are working on it is currently upscaling it to solve the Europe's problems. So that is a completely divergent kind of a situation, right? Okay, but thank you so much for your time, and it was nice connecting with you. And as you mentioned, now you know the different areas in which faculty members here at Cittara are working on.
Yeah.
So we can consider future potential opportunities for collaboration as well.
Yeah, definitely, sir. Yeah.
And then this time we could not visit, but in future, we provided the COVID allows, whenever you are coming back.
There always be possibilities, sir. We can always connect. Yeah.
Sure.
But just I would like to thank everybody for giving their time, listening to me. It was really, I really enjoyed interacting with the scientific fraternity of Cittara students as well. So I hope I was able to trigger some innovation ideas or something. So if anyone wants to reach me out, probably you can Google it and you will find my official email address. But otherwise, Professor Shah or Professor Rao and Sudha and Abhino has my personal email address as well. So if you have any question, if you want to discuss something, please feel free to email me. And it would be a pleasure interacting.
Thank you so much for the open offer. I think somebody will make use of it. Okay.
Yeah, I didn't put on I forgot to put on my slide. I should have put my email address, but yeah. So if you want, it's d.pandey@hud.ac.uk.
Okay,
so
maybe
thank you very much, sir, for your time as well. Yeah, and other faculty members. Yeah.
It was pleasure.
Dr. Daya, I must mention that right from 5:30 onwards, your smile has been continuously on. It's remarkable. I think
thank you, sir.
Keep smiling, and all the best for your sort of venture and research. And we hope we can get to collaborate with you.